Cross-Site Request Forgery is a type of attack that hackers take advantage of trust that websites have in each other to make requests on behalf of users. So this is a banking site that a user visits, and the user inputs in the token as well as the PIN. Maybe the user wants to make a certain transaction. Now, once the user logs into another site, the tokens are automatically transferred. So this nice looking site also receives the token as well as the PIN from the banking site as cookies. So this can just be a simple button on the nice looking website. Maybe click on the button to download a file. Once you click on this button, you initialize a transaction. Now, not every transaction is seen on the front end. So there can be a hidden form. And what this form is actually doing is that the form is using the token from the banking app as well as the PIN, and is transferring cash to the token of the attacker, and maybe an amount is also provided for this request. This is the cross-site request forgery. And the way it works is that hackers take advantage of cookies which contains valuable details as a result of users moving from one site to another. How can we prevent cross-site request forgery? The first method is to implement the REST principle. The REST principle stands for representational state principle. And what this principle means is that every request should perform request that they've been made to do. So a GET request should not change the information in our database. So a GET route should not look something like this, where the GET request is performing a delete action on the user 123. We saw this kind of effect in Twitter at their early stages. The second way is to implement CSRF cookies. Now, this is a very efficient way to prevent cross-site request forgery attacks. The way this works is that every browser generates these cookies, which are then stored in the server. So we have this browser and we have the server back here. So when these cookies are generated, so let's say TZX1. So when these cookies are generated in our server, they are transferred and compared to that of the browser, which also contains the same cookies. Now, when a request is made on this browser, these cookies are actually compared. So once they match, then the request can actually go through. Once you open a different website and you try and send a request, remember that the cookies that the form of your new website generates is actually different from the CSRF cookies, which are stored in the server of the browser that the request is actually being transferred to. So when this comparison is made and there is no match, then the request is actually blocked. So cross-site request forgery cookies are actually a very important and efficient way to prevent cross-site request forgery attacks. The final way to prevent CSRF attacks is to use the same site attribute. The same site attribute. So what these same sites does is that it restricts sites that we can send cookies to. There are two same site attributes. The same site strict, and we also have the same site lax. What this same site strict does is that it prevents sending cookies to any other website or any other links of any form. So once a user clicks on your link from a different site, the user has to log in again, since the sessions are not stored and cookies are not transferred to the same site that the user has already logged in from another site. With the same site lax, the cookies are transferred once it is a GET request. Not necessarily only GET request, but requests that follow the REST GET principle. That is, all requests that follow strictly GET principles. Because you can have a GET request that is actually performing a post action. As we saw in the section before, a GET request can actually be manipulated to perform a delete action on the user 123. So these are the three ways to prevent cross-site request forgery attacks. We've just at the same site principle, where we said we can use the same site strict and also the same site lax to restrict the site that we send our cookies to. We've also seen that we can actually use CSRF cookies to keep track of the sites that requests are coming from. Well, when there is a mismatch between the cookie sent from our browser and that in our server, we reject the request. And finally, we've also looked at following the REST principle, as we saw in the case of Twitter, where GET requests were actually changing details from the user account. My name is Ben, and subscribe if you learned something new. Bye.